Example 5. Suppose you scored 650 on the verbal section of the SAT. How does your score compare with the scores of the other students? We might answer this by giving the percentage of students who scored less than or equal to 650. That is, giving the percentile of the data point 650. To find the percentile, we can follow the following steps. Step 1. Calculate the z-score for the data point. Recall, the formula for the z-score is as follows. Z-score equals data point minus mean divided by the standard deviation. Our data point is 650, and you might recall that our mean is 507. In fact, both the mean and the standard deviation were given in example 1, which reads the verbal section of the SAT reasoning test is normally distributed with mean score 507 and standard deviation 111. When we substitute this in, we get the quantity 650 minus 507 divided by 111, which is approximately equal to 1.3. Now that we found the z-score for our data point, we could use table 6.2 above to find the percentile. Notice for a z-score of 1.3, the corresponding percentile is 90.32. Our next step is answering the question above by interpreting our percentile. Recall, the question above states, how does your test score compare with the scores of other students? Notice that since you scored in the 90.32 percentile, about 90.32% of all scores are less than or equal to your score of 650. Once again, when we compare your score of 650 to the scores of the other students, we note that about 90.32% of all SAT verbal scores were less than or equal to your score of 650. Example 6. The average length of illness for flu patients in a season is normally distributed, with a mean of 8 and a standard deviation of 0.9 days. What percentage of flu patients will be ill for more than 10 days? To answer this question, we will use the same steps as we used above. That is, first we will calculate the z-score for the data point. Second, we will use table 6.2 to convert our z-score to a percentile. And third, we will answer the questions by interpreting the percentile. Recall, the formula for z-score is z equals data point minus mean divided by standard deviation. Note that the horizontal axis in our distribution represents the average length of illness for flu patients in a season. From the information in the problem, we have the mean is 8 days and the standard deviation is 0.9 days. The data point we are interested in is 10 because we want to know what percentage of flu patients will be sick for more than 10 days. Substituting this into our formula, we get 10 minus 8 divided by 0.9, which is approximately equal to 2.2. Be sure when you perform this calculation, you use the correct order of operation. Since the data point and the mean are grouped together in the numerator, we should subtract them first before dividing by the standard deviation. Next, we use table 6.2 to convert our z-score of 2.2 to a percentile. According to the table, our z-score corresponds to a percentile of 98.61. Finally, we answer the questions by interpreting the percentile. The fact that the data point of 10 is in the 98.61 percentile means that 98.61% of the data, the vast majority, is less than or equal to 10. In other words, 98.61% of all patients will recover in 10 days or less. But we are interested in what percentage of flu patients will be ill for more than 10 days. To get this, we take 100% minus 98.61% and get 1.39% of flu patients will be ill for more than 10 days. Once again, since 10 is in the 98.61 percentile, about 100% minus 98.61%, or 1.39% of all flu patients will be ill for more than 10 days.